So I thought I'd show a little bit on what are called PEM studs. There's a company called PEM, which I don't know what it stands for. But anyway, they make these very cool little studs. You know, I better zoom that in. So in a previous video, I showed an old school style chassis or drill jig that I use for drilling some chassis. Well, I finally have need of all the ones I drilled, so it's time I got to put studs in them. And I know when I first started using these, I just couldn't hardly find any information on them other than I knew that they existed. I'd never used them before. I'm not sure how good this will show up in the video. I zoomed it in, but anyway, this is a 632 and this is an 832, and there's a very small set of serrations around each head, and they require a very precise hole in the whatever you're going to push them into. In this case, they go in the bottom of these chassis, and I'm not going to, all of them isn't going to show, but so you can see there's some holes drilled here, and they're I forget, they're like 3mm, whatever this required. It's got a tight tolerance. It's like +0 -1 or 2, because it displaces metal as it's forced in. When it's forced in, there's like these tiny little teeth embed themselves into the metal, and then there's a little shank on here that's just so slightly bigger than the threads. You can see they don't drop in quite flush. Well, it takes a lot of force to push these in. I believe it's oh man, I think it's 3 tons. So anyway, that's how much I give it 6,000 pounds of force. Obviously, you can't put 6,000 pounds of force on a piece of aluminum like this. So what I do, what I made, I should say, is do they show? There we go. Other way. There we go. So these are, I hate to call them arbors, but they go on the, and I'll move the camera here in a minute and show. On this end, they've got a little stub, 1/2 inch machined, and they sit into the press plate on a hydraulic press. And then, so they'll stand vertical, and then let me back the camera out. So in use, they stand up vertically like this. And then I set the chassis over it. The stud will go through the chassis and drop in to a clearance hole in this. Now this hole is a little bit bigger than obviously the size that it press fits into. So it's a loose fit and it won't jam in there. This is made out of, I want to say it's D2 tool steel. This is for the 632 size, so it gets a lot of use. Each one of these chassis has 10 of those and only 1 of the 832s. So the 832 one, which you can probably see, has a little bit bigger hole, obviously for the 832s. And it's just made out of the really cheesy mild steel bar stock you can get at Lowe's or Home Depot. Anyway, I'll move the camera over and show how the press works. It's going to be really short because if you press 1, it's the same as pressing 100, and it press is noisy. So this our hydraulic press, you know, the top-down view. It's just got a pressure gauge up there. It's just a kind of a cheap one. What is a little different about this one is it's pneumatic assisted. So if you look now, you can see that there's the main hydraulic cylinder and the standard place you'd put a arm in, not an arm, handle. I guess handle is the right word. But anyway, you can see that there's also a pneumatic cylinder on there going down, and then there's a water remover and lubricator regulator combination, and I've got a foot pedal on the ground. So because I have to have enough stroke to be able to get the stud in there and the chassis in there. So I got about, you know, maybe 1 3/4 inches. And if you sat here and cranked the handle, it'd take all day. So it's It's got a pneumatic assist, which works really, really well. It's been a lifesaver with this thing. So let me grab a couple studs and I'll show you how it works. And then that'll be enough of this, because like I said, you don't want to watch them all. So this is our little backing arbor. And what I do is I just kind of line it up with the main one. Doesn't have to be super good. This is actually pretty flat on there. And we just back it off enough to get the chassis and the stud in there. And then I pretty much pre-stud the chassis, and then we can just move it around and get her done. Just got our hearing protection for this, because with the pneumatic, you know, you're up close. It's pretty loud, and after you've done 60 or 70 of them, it's a lot of noise. Plus the compressor will kick on after about a dozen of these. 60-gallon tank. This thing just burns through it. So anyway, I'll show real quick how a couple of these go, and then that'll be it. Just whoops, go this way. Slide it in. I'll line the stud up in a little hole. They just drop in. And they basically stand on it. You can tell more or less by the sound when it starts getting compressed. That's got 3 tons on it right there. So we just lift it up, move it to the next one. That's as simple as that. I forgot I didn't wipe the leaked oil off of there, so you can see there's a little oil in there, but these things are absolutely flush with the, I don't know if it shows up. Anyway, they come out absolutely flush with the bottom of the chassis, and this is, you know, it's the bottom of a piece of equipment, so nobody really cares. They're silver instead of black, but they're smooth and flush, and they absolutely don't come out. You have to beat them out with a big hammer, and it ruins the metal trying to get it out. So anyway, I'm going to actually get to work. So hopefully somebody found this a little bit useful and interesting. Thanks for watching. Just a real quick shot of what one of these looks like, all with all the studs pressed in. You zoom in and you can see there's a little bit of metal displacement as they go in. See if this will focus. So that's actually a 632 stud. So you can see, if you look around the very base of that, you can see a little bit of metal displacement as it pushes through the aluminum. Those chassis are 2mm aluminum. So like I said, once these are pressed in, they're there. Unless you want to destroy it, they're pretty much there. You could make some kind of backer with a little hole in it and press it out, I suppose, but they really stay in there. They may, I don't even know, maybe there's enough pressure that they cold weld themselves. I'm not sure. Anyway, just thought I'd show that, and thanks again. If you watched last week, there was the misstep of trying to use this just a little fixture plate to drill some holes in this amplifier chassis. I didn't have long enough screws. Unfortunately, the big box stores don't have that kind of stuff. Fortunately, because I live in the country, we still have small hardware stores and farm and ranch stores who do carry that. So unfortunately, the only 25mm long 6mm 6x25 screws they had are fine, but they have a Phillips head, so yeah, you can't get them as tight as I want. They had some nice hex head. I don't know what grade they are, but they're good. Anyway, they're good screws. Problem is they're 35mm. If I screw them in here with a plate, of course they're too long. I'm not going to cut them. So we'll just use a couple washers. I got our got our bottom plate. I'm just going to actually stick this on here, just to it sticks up just proud of the edge a little bit, so that'll protect it a little bit. So I'm going to do that. And I know you probably will never see this, John, but at the end of last summer, I had some correspondence with John Mills over in the UK when I bought one of his t-shirts, Double Boost. And I was joking about, I had a guy giving me a bunch of end mills, and I said, well, I ordered a shirt, it never got here, it got lost in the post. He sent me a replacement, no cost, he wouldn't accept anything, very cool. And I said, well, I'll send you the shirt back if it ever shows up. He goes, send me some end mills. I said, okay. I was not really a joke, and I really meant to send him some end mills. So I collected a bag of end mills, various sizes, really, really small through 3/4 inch. And I don't know how it happened, but these got misplaced and I never mailed them. So John, you'll never see this probably, but these will go out in the post on Monday. You should have them soon. I'm sorry, I did collect them. I fully meant to spend them. They got stuck over there on a table, buried under some other junk, and they're still here, but I found them today. So John, you'll get some end mills real soon. It's really sad that happens, but it is what it is. So anyway, we'll put this together real quick, and should work good. Hopefully the screws with the washers will tighten down. We'll find out real quick. I actually haven't tried it, but I know they should. I tried it with one washer and they didn't fit, so they were just a little too long. I just didn't want to cut them. It's too much hassle. So we'll just stick them on here with some double washers. So looks like we're going to be good. And put it in the mill, verify. Oh, we'll cover it with our friend Mr. Tape, because spinning chips tend to scratch up the anodize on these, and can't afford to do that. So yeah, these snug up good. That's why I just didn't want to use the Phillips, because you just can't get them very tight. I don't want them, you know, massively tight, but tighter than you can typically get a Phillips. So we're good. That'll be our piece. Clamp it in the vise this way. Drill our row of holes in there. I've got to go get my drawing so I get them in the right place and the right number. I think they're about 20 millimeters offset and 50 from each end. Because it is metric, so it's just as easy to do it in millimeters. Let's see. So we got two options for tape, right? We got blue painter's tape or the regular masking tape. For this, I'm definitely going with the blue painter's tape just because it's easier to get off. You know, a lot of things it falls off too easy, and it's hard to, if you write on it with marker, it's hard to see. But for stuff like this, where you just want it to as a protective cover, it works out really well. It might actually, I should have gone the other way. So I'm just going to cover this up with tape. Might actually do a little layout on here just as a sanity check for when I go to drill the holes, so that I don't screw up, even though I'll touch off, use the DRO. Visual markings are, for me, a good thing. So we'll cover this up. There's a second one to do. I'm certainly not going to show that. I am going to put a little on the side so I have a place to touch off with the edge finder. It's not super critical, but you know, we'll get it within a couple thousandths anyway of where it needs to be. It's visual, so it needs to not look crappy. So we'll make a real measurement, touch off, and make sure we're good. I'm gonna go get my print. I'll be right back. You may recall from a previous video, I showed this amplifier chassis I had to drill some holes in. I made a little fixture plate and I didn't have the right screws. Well, obviously that's been taken care of. and I already did one of these. I wasn't going to show anything, but I thought I'd show so the DRO has a function where you can define a linear array, and in this case we'll use it for holes. So I'm going to try something new, which is using 2 cameras, and see if I can show the DRO and the operation at the same time. I have no idea if this will work at all, but let's see. So the first thing to do is we're going to put this back in inch mode, and I've already run the edge finder, but we'll just run it again really quick in case things have changed since before. So we'll pick up our x-axis. This brakes. Okay, X says 0.1 on the DRO. That's because I've already done it, and that accounts for the 200 thousandths of the edge finder. So X is still valid. I don't have to reset it. Pretty sure Y will still be good. So there's masking tape on here to protect the finish, which does have some thickness, but this is just a cosmetic array of holes. So if it's off a few thousandths, it doesn't matter, and I'm not going to worry about compensating for it. So there's the Y brake, and it is exactly 0.1, so that's also correct. So our chassis is made in England, in the UK. So it's actually 220 millimeters by 300. So we're going to come in 50 millimeters and drill the holes 12 millimeters apart. That way it's just a nice even spacing that works out. So we're going to set the DRO to millimeters. So we're going to go 50 millimeters on our X as a starting point. If I'm not in the way of the camera, we'll see how this works out. Okay. Whoop, too far. All right, there's 50 that way, and we're going to come in 20. But before I do that, I should put a drill in there instead of the edge finder. So this is actually going to be a 3-step. I'm just going to spot it with a center drill, then drill through holes, and then use a countersink to just put a little chamfer on these so they look nice. And then instead of changing the tool every time, I'm going to use the linear array function, and it makes it really easy to hit the same spot every time. Obviously you can do it without that, that's no problem, but as you'll see here in a minute, it just makes it's real slick. It makes it almost foolproof, and in my case that's important. So we're 20 millimeters in, 50 millimeters from the edge. So we push our little button that says linear array. So the first thing we is the line angle. Well, on this one, if you want to go from left to right, you have to enter 180 to go in a straight line. Then we hit our next one. Our line distance in this case is 120 millimeters. We get next, and we've got a number of holes. We're going 11 holes. And then that's next. And it says hole 1. It shows 0, 0. So as we go through, we'll go to hole 2, and it'll say move over 12 millimeters, which you can see right now we're not going to do, but because we got to drill the first hole first. We'll go back to 0, and then we'll just pop along. This actually goes really fast. So my center drill's not in the chuck centered. That looked, I don't know if that showed up on camera, but it did not look good. So we're on hole 1. I'm going to lock our Y just so it doesn't move. Spot it. You can see, just go down to where X shows 0. Spot the next one. And just continue on. It doesn't. One of the nice things is when you get to the last hole, If you hit the button again, it will not cycle back around to 1. So it won't let you, or at least it tries to prevent you from doing anything monumentally stupid. Like I said, almost foolproof. Of course, like anything else, if you don't pay attention, bad things happen. Hopefully you can see the DRO around my shoulder. I'm trying to stay out of the way. Alright, there's 10. And 11. As I said, if I push it again, it'll just beep at me and won't let me go any further. So there's our array of little started holes, very nice and clean. So now we'll swap to a, in this case, a 5/16 drill bit. Where, even though these are, everything else is metric, 5/16 is so close to 8 millimeters for, you know, it's a ventilation hole, so it doesn't really matter. All right, it's down far enough. Okay. And so I guess we're good to go. And I'm not going to go back to hole 1. We're just going to go to 11 and go the other direction. No difference. Got masking tape on here for the inevitable spinning chips that will tend to grab this. So now we go back to hole 10. It says -12, so we go back the other way. Whoop. Ah, there we are. Go back the other way 12 millimeters and just keep going until we're done. Okay, so that's done. Now we want to put a little tiny chamfer on those and make them all consistent. I'll show a quick way to do that. So this is just a 90 degree, no, take it back. It's an 82 degree countersink, and this one just cuts so good. So we're going to put it in, and part of the reason I didn't want to take it out is even though I've got it bottomed in the chuck, the depth changes a little, and I want all these to, because they're cosmetic, I want them to all look the same. So I'm going to use a quickie quill stop. So we'll get this down somewhere where I like where the handle stops, somewhere about there. Put this on, which you can't see. Anyway, so that gives us a positive stop on the quill. I could screw the one that's on the mill up. So then we'll just bring the table up. And then we'll put the mill in back gear. So we're just going to run this thing pretty slow. That's 160 RPM. Basically, I'm just going to bring the table up until it touches, and then go about another 10 thousandths or so. So as soon as I see a little bit of chip right there, let's lift this out and look at it. I think I'll give it about, there's another 5. See how that looks. And give it another 2. Now I like the look of that. So we'll just leave the Z alone. Go that, and we'll just go down our row of holes one more time. Same drill. since this will get us within, you know, a tenth or so, just line up, go down against the quill stop, let it spin nice, looks great. As they say, lather, rinse, and repeat. Okay. So, let's show you how it looks real quick. Oh, the brush ended up behind the mill. So we're not going to go get it. Not right now. So those, blow it out, clean it up. Got to deburr the inside, but you know, it's very smooth, no burrs. Looks good. All right, hopefully the owner will be extremely happy with it, and I think he will be. I've got to do the bottom plate, but that's easy. I just mounted in the vise. Same thing. Drill them and all that. Anyway, hopefully somebody finds that interesting or useful. So that's the linear hole array. That sounds more like it. I couldn't get the name right earlier.